Okay, this is Aubrey and Owen and Callie. Hallie. That sounded like Callie because I was like, okay. Hallie. This is 10-1, circles and circumference. You should know most of this stuff. We're going to get into some technicalities. No, I know what you're doing.
I'm doing my English.
If you don't want to listen, then we'll do it after school. I'll just wait for everybody and we'll do it after school. Okay, let's get going. Circles and circumference. Let's talk about this thing. This guy's name is Circle what? Circle C. You either call him CIRCLEC or Circle C. You see my circle with a dot? This is the symbol for Circle C, right? Okay. Circle C named with the center. Okay. There are a couple different things in here. We have something called a diameter. What is the diameter? DE, it's all the way across. We have a radius. Actually, here we have how many? We have 3. What are they? Now, hold on. When we name a radius, we usually start with the center and go out. So, CE, CF, CD. Yeah? What is AB then? What's AB? What's this called? Nope.
Chord.
It's called a chord. C-H-O-R-D. It's called a chord. Okay, now technically there is another chord. The definition of chord, it means that it touches the outside of the circle. DE is also a chord, but DE is the diameter, right? It's a special type of chord, right? So diameter is a chord that goes through the center of the circle. Got it? Okay, all of the things. All right, let's go to example 1. Identifying. Radii, it is the plural of radius. Radii. Yeah, so if you're looking at example 1, you're looking at this word right here that I'm circled in black. That's radii. That means the plural of radius, okay? There are how many radii in this thing? There are 4, right? 1, 2, 3, 4. Okay, they are named here. They have XV, XT, what else? XU and XZ. Fill in the blanks, okay? 2 chords are shown. One of them is RS, and the other one is ZT, but ZT is special. He is also the diameter. He is also the diameter, okay? So there is that. Name, identify a radius, a chord, and a diameter of the circle. There you go. That's example 1. Got it? Okay, we can either call this circle what? We talk about his name, C-I-R-C-L-E, circle X or circle X, right? If you want to do the symbols. Got it? That's how you name him. That's how you name him. All right, ready? Radius and diameter. It says TU. Right here is 14 feet. They want to know what the radius is of the circle. The radius is half of the diameter, so that would just be 7 feet. Do we know that? Yes, radius half a diameter. They like really baby step you into this. Like this is a Good Friday exercise, right? 7 feet. Okay, find the circumference. Okay, there are 2 formulas that you should know. You should know circumference and you should know area. Put these down somewhere where you can find them. Okay? One of them is what? 2 pi r. Which one is that? 2 pi r is the circumference. And the other one is pi r squared. Now, note this. Everybody watch. Both of those formulas involved a pi, an r, and the number 2. Area is in units squared, right? The label that you put on the back of area is always like feet squared or inches squared. Therefore, the square is the one that goes with area, right? Okay? Now, Brady, it is not 2 pi r squared. That's not a thing, right? There is no thing that is 2 pi r squared, okay? All right, so area, circumference. If you don't know those already, work on memorizing those over the next, couple weeks.
Why not just do diameter times pi?
Right. Circumference, if you want to put next to circumference, this is also diameter times pi. So if they give you the diameter, right? 2 times the radius is also the diameter, right? Okay. I don't know. You could also write area as pi times d over 2 squared.
Yeah, but that's a pain in the butt.
But that is a pain in the butt, you're right. Okay. So we could get really tricky into it and all the things, right? But that's okay. All right. Traffic circles, also known as roundabouts. Have you guys had the privilege of driving in a roundabout? I hate them. them. I hate them so much.
Yeah, Liz, you're not ever going backwards through a roundabout.
So I have a funny story about roundabouts. Are you ready for this?
Over them.
Just go over them, just ramp it. Yeah, okay. So here's my funny story about roundabouts. So roundabouts used to not be a thing like in Nebraska, and now they're getting to be more prevalent, right? But over in England, like London, England, they're like everywhere. Like they use those things at every intersection just about, okay? So when I was in college, I went over to England for 2 weeks, like as a whatever transfer student. I like student taught over there kind of for 2 weeks. 2 weeks, it was only 2 weeks. But anyway, they do roundabouts, but also their cars are backwards, right? So you drive on the passenger side, you passenger on the driver's side, right? Like the cars flip-flop. And the lady that I lived with while I was over there, because we were like in a student whatever, like we were matched with a family and stuff. I lived with her, and she would drive us around everywhere, whatever. And she would hit those roundabouts, I swear to you, going like 50 mile an hour, which seems like super fast. Yeah. So I'm sitting there in the passenger seat, which is actually the normal driver's seat for us, and I could just feel my foot like going down, like, oh, push the brake, but there's no brake there, you know, because I'm like in the what should be the driver's side, but I'm actually the passenger. Oh. I had like such like roller coaster like tummy. It was awful after, that 2 weeks. Roundabouts. Awful, awful, awful. Okay, so roundabout, traffic circles. I'm going to skip to the middle sentence where it has all the information, and it says, a car enters the traffic circle and is 18 meters from the center. What does that tell you? The radius is 18 meters. Perfect. They want to know what is the circumference of the car's path. So I'm going to plug 18 in for the radius. 2 times 18 is 36, and I just take 36 pi. Now, here's what I don't want you to do. Are you listening? I don't want you to type in 3.14 into your calculator when you use pi. You have a pi button.
113.1.
What?
113.1.
I should say approximately 113.1 meters squared, not squared. Not square, just circumference, right? Do you find your pi button?
Yep.
Do you need me to come find your pi button?
No.
You got it? Your pi button is like, you know where it's at. Okay. All right, there you go. Good circumference?
Where's my pi button, actually?
I don't know.
On the bottom by the times 10. On the very bottom.
Found it.
Okay. Next page, example 4. Finding the diameter and radius. Now we got to think a little bit, right? It says find the diameter and the radius if the circumference is 77.8. Okay, how do we find circumference? 2 pi r, right? And circumference, they're giving me this number. This is 77.8. So if I'm trying to find the radius, what are you going to do?
Divide by 2.
Divide by 2 pi. You're like working backwards, right? 77.8 divided by 2 pi. The radius is something. What do you got?
122.2.
What?
Yeah.
Oh!
What?
Also a problem. You ready? Here's what's happening. Everybody watch. This is a fun calculator moment. If you do this, if you go to type this guy in and you say 77.8 divided by 2 pi, you know what it's going to do? It's going to take 77.8 divided by 2 and then multiply that number by pi. But I want the pi to be in the bottom. Okay? So you can either divide by 2 pi in parentheses, or you can divide by 2 divide by pi. Okay? Or if you have a calculator that, if you got a calculator that already does it in fractions,
Oh, I'm good. 4.4.
That was my first thing.
that's fine. Then you have a good calculator. What'd you get?
12.4.
12.4. What is that?
The radius.
That's the radius. Equals the radius. So the diameter then is 24.8. And that is in what units? Centimeters? Centimeters squared.
No.
Just centimeters, right? Okay, good? All right, let's do one more. We got this thing going on. This kind of like, example 5. This is kind of hard for people to see. Do you see this? We have circles that are like overlapping each other, right? They're like little bubbles that overlap, okay? All right, let's talk about this. It says, real quick, go to this example. This is hard for people to see. The diameter of circle K is 12 units, okay? Do you see the outer edges of circle K right here? It goes from here to here. That is 12. So I can label this guy right here as 6. Do you see that?
Yep.
Okay. Also, the diameter of the other one is 20. So that means
Hey, E is 10.
this is 10, and I'm going to go below. And this is 10, yeah? Do you see that? 10 and 10? They say JD is 8. So from here to here is 8.
That is 2.
That means this is 2,
And the other one's 4.
and the other one is?
4.
Do you see how she mapped that out? Okay. Not real hard. What are they asking for? Find EK. EK is
4.
4. Got it? Like a nice Friday day, right?
Yeah.
Circumference, naming circles, finding things. Not too bad, right?
1 through 16 all, please.
Makes me not feel retarded.
No, 1 through
1
14.
through 16 evens.
1 through 14.
1 through 16 all.
1 through 3. No.
I've done 1 through 16 all.
1 through 3.
You're already done with all of them? 1 through 16. Well, I'll just add stuff, right? And circums and circles and circumference. Let's do.
1 through 16 all.
Yeah, but you got to do some of the other ones.
Like what? Don't.
We'll do 1 through 16 all, but then you got to do 18, 22, 24, 26,
It's
That's
Friday.
it.
30.
Oh my god.
There you go.
I'm not getting this done.
Yeah, there's no way I'm getting
What are you talking about?
So what?
Hey, what did you say?
1 through 16 all.
How do you explain?
No.
Can you
Don't
go
look
back
at
and
this
find
top.
the diameter?
18. 1 through 16 all. 18, 22, 24, 26, 30.
18, 20.
Jacob, have you started?
There you go. 1 through 16 all and 18, 22, 24, 26, 30. 18, 22, 24, 36, no, 26, 30.
So it's the 256
There you go. Whoop, 573.
18, 22, 24, 26, and 30.
There you go.
40.7 and 81.5.
All right. Goodbye, people watching the video.